Hello everyone, my name is Marty Rozmanith. I'm really glad to be here today. If I follow Anthony's lead, I'm the guy apologizing for Revit from 1999 through 2006. But I'm not actually apologizing because I remember what it was like to try and coordinate across 500 DWG files before that. So it's a little bit cheeky. So of course, it's a very UK thing to do. And I'm sure I said that many times over the last 20 years. But today, actually, I want to talk about the next thing, which is Skema. Skema is very different from Revit. It's very different from anything that is like a BIM tool on the web. Skema is more of a meta modeler. So we're like an authoring tool that collapses time on a project. Rather than working with individual objects, you work like a meta BIM, chunks of the building at a time, and our goal is to be the fastest thing to get to 60% complete. It might be 62% complete, it might be 75, 58, I don't know. The point is, it's a different process that's meant to accelerate things. And it's based off this chunking idea, which was originally described more than 20 years ago in this book called Refabricating Architecture, so I'm calling this Refabricating Architecture. And that's how you can reach me if you're interested in what I've got to show you today. And like most of the very courageous startups here, we're going to do a live demo as part of this. So the concept of refabricating architecture was very simple. It's don't do everything on the site where it takes the most time and it can get in the most problems. Instead, chunk things up, and it's much faster because you have fewer joints to figure out. Well, we thought if this can work physically, and this has evolved into prefab and modular and modern methods of construction and all the things you've heard, why don't we do it virtually in the BIM system? So what we do is we start with chunks of BIM data. Now I'm going to show you Revit. Doesn't necessarily have to be Revit data, but we like Revit, so we're doing it with Revit. So what we have is a conceptual design environment that's coupled with a BIM automation engine. And I'm going to show you how it works. And the idea is that you can work like you would in many of the tools that you see for doing early project modeling with sustainability analysis, block and stack, performa metrics, those sorts of things. But at the end of it, you don't just get a bunch of cubes, you actually get high LOD building out of it, which advances you many months into where you would normally be if you were using a traditional BIM tool that worked with wall-door window. So what is the benefit? Well, first of all, for owners and architects, there's significant time savings. And there's an increase in quality and sustainability, and I'll talk about that as I show you the demo. For architects, because of this time savings, we're giving you back essentially project budget. So you can choose to spend that by doing other design that's more interesting because we do the production lift. So the SWAP guys had a very good definition of what drudgery is. So we also eliminate drudgery. We do it a different way, but the whole goal is to eliminate the drudgery, or keep some of that as profit on the job. So systematically, you can make the office more profitable by using this approach. Also, because you can resolve the conceptual stuff against the developer's requirements much more quickly, you can spend a lot less effort winning work and have the ability to take on more projects with the same number of people that you have. So I'm just going to show you a real quick, this is not paying attention to what I'm doing here. All right, so I'm going to do maybe a 48-second demo here before I jump into live product just to get some stuff out of the way. So you work in a context. Like many things, we take the site context from OpenStreetMaps. We have a terrain model. You have some simple massing tools, very SketchUp-like, push, pull, slice, those sorts of things. We have some things that can automatically generate mesh, that like computational tools, Voronoi, things that you've done potentially in Grasshopper. And then where it gets interesting is you can save multiple of these options, assign uses, look at the analytics of various schemes so you can compare them against each other. And where the magic really happens is where we get into these Jello cubes. Because what we've done is we've built a catalog of the designs that you're going to reuse from the 15 years of Revit history you have on your file server. And we use those and abstract them into those Jello cubes. And then once you're done, you can generate a building, or you can just take the concept, send a link to your owner. It's very, this is all on the cloud, runs in a web browser, on any platform. And again, like some of the startups, we don't have any dependency on Autodesk. It's all our own code. We did all the hard part. So, how does it work? So rather than work with walls, doors, windows, we work with an architect who gives us some of their previous projects, say 2 or 3 Revit models. We take that, we build a catalog where we harvest what they're going to use. I'm showing you a multifamily residential example, seems to be very popular here. The goal, though, is do any building type that has a programmatically driven layout process. And we then take what is repeatable in that design and make chunks out of it that contain circulation, exiting, and whatever repeatable unit we have. This was originally developed for modular multifamily, and we are now bringing it so that it doesn't have to be modular. It can have primary frame. It doesn't have to be residential. It can be other types of projects like healthcare, schools, or anything you want. Probably nothing like stadiums or anything like that. Why does this keep going in a random fashion? All right. At any point, you can do sustainability analysis, and it's probably best for me to just march through it and get up to a live demo since it's going to be hit better. So might as well just show you what it looks like. So this is Skema. I already showed you how to create a site. As you can see, I've got a bunch of different options. I'm just making a new one here. Like I said, we have a bunch of different massing tools. The video kind of showed you the SketchUp sketching version of this with the slicing. I'm going to show you a tool I like, which is the polyline tool, because it's super fast for laying something out. So we have some nice, this is a detail, but it's interesting. So if I'm in feet inches here, if I do 300, right now I've got it fixed length because I've typed in, but now say I want to be perpendicular to this site edge. You see it's very subtle, but I can get a 300-foot edge of a building perpendicular to that site. I can move off of that edge. I have the snapping is very subtle, but it's very, very helpful. One of the things I'll do, I'm gonna just, because I know I'm gonna apply a few things here, I'm gonna set the width of this, and then we have a building. Not gonna do too much editing because I've got some time constraints, but we can take things like, bump up the number of floors, change the number of segments in this polyline. So this is a building that acts like a polyline. So there's like I said, various massing tools. I have tabbing that goes between different selections. So I can select the floor, I can select this block, I can select the whole building. Right? If I select the building, I can say, give me more parts. Right? So lots and lots of parts. This thing behaves like a polyline. Right? I can do that with it. I can do interesting things with it. I will tell you that the massing tools have the ability to outsmart the packing algorithm. So if at the end of this you decide to go to Skema and try it out, it likes right angles right now, and we're in the middle of adding all that functionality, so no matter what you do with it, it'll solve it. So here we have, what I'm going to do is I'm going to just take this and I'm going to make it a little bit simpler so that it'll solve more quickly. So let's lower the number of parts back down to where we were. Now, again, we can say, what's the use of this? Your residential, I'm just gonna make it easy. Everybody's residential. And once you're happy with this, the other thing too is, basement conditions. So this site actually has topography. I'm gonna take this and just give it some a good height that I know works for this a lot, so that it's not buried in the dirt. Say something like that. And now it was where we get into actually getting into something interesting. So let's say I've done some options. I like this. Let's do a sun study. In this case, it's going to do something approximate. If I dial it down, this gives me, it's a radiation analysis of sunlight hours falling on different parts of the building or the site. The radius of this circle controls whether I do additional buildings as part of the calculation. So we have a number of sustainability measures in here. The vertical sky component, something very, very popular here, is in there. We've also just, to demonstrate the concept, we believe that there's going to be a future ecosystem of connected apps. So for instance, we have another daylighting analysis done through Cove Tool. So we have an integration where We pass our geometry to Cove Tool. It creates a project on their side. They take the geometry, run their daylighting study, give us back the results. We replay them in our UI, and then you can see the results without having to go through all the steps of doing the export, going to Cove Tool, creating the project, importing the geometry, running the analysis, exporting it, bring it back here. So very web servicey kind of workflows, and that's the whole idea, is that you can connect these things into a tool chain. I'll talk a little bit about that in a minute. Where the rubber meets the road is when we want to take this and turn it into a building. So what we do once we get there, we're gonna apply one of these building catalogs. So if I start with our Blue Ocean catalog, let's see, we'll get a result. This is where it gets interesting. Now we get into block and stack. So what you see is we've taken those chunks of buildings, which represent 1-bedroom units in orange, 2-bedroom units in blue, and 3-bedroom units in red, and we've used the solver to solve this packing of this massing. Now, of course, these units, because of whatever width they are, have left us with some leftover space. So what we expect is every architect using this is going to have multiple catalogs. You might be doing schools with one catalog. You might be doing healthcare with a catalog. You might have multiple multi-family catalogs with different size units. That's what I have here. So instead of using this one, I'm going to apply this one, and you'll see I get a whole different packing methodology because I have a different unit size, I have a different mix. And so with this, I can now get a better result for my massing with the size of the units. And what I've done is I've gotten just a default of 1, 2-bedroom and studios. If I really wanted lots of 1-bedrooms, I can just crank up my percentage of 1-bedrooms. And what you'll see, let's not say 100, let's say 85 maybe. What you'll see is I have a lot more orange cubes now because I've told it I'm trying to get to 85% 1-bedrooms when I got to 62. So with this particular layout, it's really hard to get that many 1-bedrooms in it because of the constraints of the packing algorithm that I have that I took from the previous Revit units that are in here. Let's say for me, this is good enough. I could do another option and save it. I'll just save this one. When you want to then take a result like this and get to something that, for instance, could be loaded into Revit and fast forward you that couple of months so you can then do the drawings and get paid for it, you click this little preview button. So when I click this, it's going to generate a building. Now this happens on the back end. So we've got about 5 years of development into this code base. So there's a whole bunch of heavy duty stuff behind this so you can see the easy to use stuff. And use it this easily. So the other thing to note is that what we're generating is an architectural model. And so I'm going to just jump over while this is, so as it calculates, now this is actually the most heavy duty catalog that we have. This has kitchens and furniture and all kinds of stuff in it. As it thinks on the back end, it's going to throb, which tells you it's thinking. And when it comes back, it's going to basically do a couple months of work in about 25 seconds. And that is our goal, like I said, is to get to 60% complete. So in many of these programmatically driven buildings, in an apartment building, you're going to have a lobby, you're going to have a gym, amenities, all sorts of things where it's not something you're necessarily reusing from a past project. Could be, but in many cases you might have a parking podium, you might have mixed uses in that parking podium. And so the idea there is that we will generate as much as we can based on whatever we've harvested from the previous projects. And then you take the result and do the rest of it in Revit the way that you do today, or in whatever BIM tool is your choice. For us, we're really format agnostic. Of course, we're just doing the Revit stuff because it's what we like to use. I'm going to go to my slides for a minute. I'll come back because this is thinking pretty hard. And I'll just do them this way instead of going to presenter mode for a minute. The idea is that we calculate that on the back end, and then we can preview that in Skema. So we preview this in Skema. Let's see, did it come back yet? Oh yeah, so you see calculation finished, fetching model, and then what it'll do is it will get rid of the cubes and it will put the LOD 350 bin model in its place. And I had the R&D team implement a feature for me just so I could demo it here. You could go into the back end and you could clip the top off so you could see inside and see all the stuff. And I said, no, I don't want to go to the back end. Just tell me how I can do it right in Skema. So they put this clipping feature in here so I can just say that. And now you can see in the building, we have all this stuff. So, right, this is the kind of data that we're generating from this process. And this is what you would then take out to whatever bin tool of your choice. And instead of having people work for weeks and weeks and weeks to do this, it comes out of Skema this way. The reason that's important is that this is production data with the dimensions in it. There are people doing blocking and stabbing with Grasshopper, and then they take the results of that. Some team goes and works in a BIM tool for a couple months, and then later you find that the two don't match anymore because people made decisions and kind of moved things, and the dimensions changed a little bit, and then you added that up over the length of a building, and now you've got problems. Because of the way that we do it, whatever is in the concept is going to exactly match the production data that comes out of it, and that's an important distinction. All right, so what have we learned? So we can calculate the building, then fetch it, put it in place so you can preview it. We can then take that into Revit so that you get that data. And I'm just going to show you, this is actual data from an actual project in a real place in Boston. I'm just spinning around the Revit data so that you can see just how detailed it is. And then one of the things which I didn't think we would be here before, but I've worked with a lot of great software teams. So we really have a dream team. They're moving very fast. You can kind of see the structure of the data. When you open this in Revit, what you're going to get is a bunch of linked files and groups in them. And if you want to work on the data as if it were something you've drawn, you just bind the links and explode the groups. Or you can leave it grouped and manage it that way and make one change and have it ripple. But we've actually, generated construction drawings from this just to show you. These drawings were done completely automatically, no human intervention to them. So it's an automated process, and the goal is to just fast forward your project team in time so that you don't have to spend the team hours on doing the drudgery. And that's the idea. So here's just another example that we did. TVS Design in Atlanta graciously allowed us to share some of the workflow stuff that we did to show this. So mass modeling, we apply the concept, that does the blocking stacking, we calculate the 350 and preview it in Skema, and then we can take it to Revit. And then I was listening to Anthony's presentation and said, well, we can also take it to IFC, Hypar, Snaptrude, Conic. It's fine with me. The idea is we're not a collaboration system as much as we are a fast forward button that you use at the beginning of the project so that you then get something that you can then collaborate on. However, the idea is that you can take versions back, you can then sync changes. So those are all workflows where we're working. Now, one of the things I didn't cover is that we will be working on so if I go back to the example of the building here with the LOD 350 preview, I'll turn off the mask there. We anticipate another checkbox here, with this one with an A over it and that one with an S over it, where we have primary structure. So you can generate the high LOD for one or the other or both together. And then my most fun tool in Revit I love is the demolition hammer. We can just tell something to go away and it goes away. Now, of course, that will create problems for a structural engineer, but that's a collaboration method where we can say, no, this column needs to be somewhere else. And so there's very interesting things that we can do generatively to start coordinating architecture and primary structure, and then take the results into collaborative platforms where each individual party can then develop it in the way they need to develop it. So in this case, we're doing that with Thornton Tomasetti with a ML tool for primary structure they have called Asterisk. So between Asterisk and Cove Tool and some of the other web-based softwares that are here, I already saw today in the session before lunch a great thing that would take our LOD 350 model and solve product manufacturer stuff to take it to LED 400. And then of course, when Francesco is here, all of these things have the outlets and the air diffusers in the ceilings and all of the terminal points for MEP systems. Really all you need to be able to have Augmenta lay out all of the MEP systems is to have high LOD architecture, high LOD structure, and what equipment's going in the building, and Augmenta should be able to route all of that. So we really have, we're really on the cusp, I think, at an inflection point where we have generative systems that can work collaboratively to solve some of these problems, speed up the process, and then give us better workflows to resolve the issues that we have to do just because we're professionals working on a project. So with that, I'm going to wrap it up. These are the outcomes. I mean, significant time savings. So the part I'm showing you is maybe, we typically do this in a charrette with an architecture firm. In a few hours, they've done buildings that would have taken a team of people a couple months to do. Of course, they're going to take some of that time, do more design, do better design, do sustainability analysis, things they weren't doing today because they didn't have enough time. So, we anticipate the net will be maybe 50% time savings on the project. The idea is that we eliminate the drudgery so you can spend more time in design instead of production. Because we're reusing things you've done before, there's a metric in the manufacturing industries for automotive and aerospace and others that's called first pass design quality. That's not a metric that exists in AEC, and it's because a lot of stuff starts from a blank page. But because of this approach of using chunks and then reusing chunks that have already been built and sort of quality checked, you increase the first pass design quality. And that is just inherent in the system because of the way that we've organized it. Again, depending on how the architect chooses to spend the fee budget that we've released for them, they can see some dramatic increases in the project profitability. They can spend less effort winning work. They can also take on more work with the same people, which means not only can they make the projects more profitable, but they can expand the revenue base of the firm without having to hire. So there's two different ways that the firm gets healthier. So part of our sustainability measures is not just make the projects more sustainable, but make the practice of architecture more sustainable. Because I think, people are here trying to innovate because they see some of the threats to the potential practice here. We're putting more AI into the layout tool. Right now, I showed you like the magic solve with one button. It's going to be more of an interactive process that looks like this, where we solve circulation, then exiting, and then when we have a shape to fill in, we'll use machine learning to morph some of the components to that. And so we are very open. Please come talk to us. We're early in this journey. We're looking for funding. We're looking for partner architects that want to work with us. Please reach out to us. And of course, we're shipping. So you can go there and as part of Next Build, Next Dev, get a 60-day trial of Skema and use it yourself. You'll have the layout catalogs that I showed you here. But otherwise, the architects we work with, they have their own logos on theirs. Any data that we get from them is under NDA. If you share data with us, it never goes to any other architect. It's part of your IP that is considered not shareable. Right? So just know that as well. Questions? Thanks.